this paper because he couldn't attend this conference. Well, it is the modeling temporal structure with LSTM for online action detection. So what is online action detection? Well, in the normal action classification, the video only contains the action frames, and the task is to identify the actions. And for the traditional action detection, the video contains several actions, but also some uninteresting frames. The system needs to watch the whole video and then decide what are the actions and when the action happened. Well, for the online action detections, the system will receive the input frame by frame and make the decisions after each frame. And so there is no future information. Well, there has a lot of applications like detecting the dangerous actions in time to allow for the interventions. Well, we use LSTM for this system because LSTM is good for online action detection. For the long-term dependencies between actions needs to be modeled because it is quite important. The real-life actions are not independent from each other. Well, we usually first take potato and take knife before we can cut the potato. Well, for the traditional approach, we train a CNN that can recognize the actions based on one frame, and then we extract the CNN features for every frame, and then we train a LSTM with these features as input. And for the LSTM, we have two tasks. The first one is to interpret the high-dimensional input, and the second one is to model the temporal dynamics. Well, this is our main contribution of this paper, where we propose the two-stream feedback network. And you can see for the frame representation, it is a standard 4096 dimensional CNN features, and it would be sent to the upper stream LSTM, whose task is to interpret as the input. Interpret the inputs, but can also know some basic temporal patterns. And the lower stream LSTM, its main task is to interpret the temporal patterns. Well, then there is another combination unit. We have several multiple strategies like sum or concatenation, and then there is an optional LSTM layer. Well, experimentally proved to make the system more robust to noisy frame. And the output would be a class probability, a vector with one value per class. And for the lower stream LSTM, we take the output of the previous frame as an input. The advantages of system is the first, the lower stream has no information on current frame and needs temporal model, and the lower stream has a low dimensional input, which is easy to interpret. Well, we tested on 3 different datasets. The first one, we created an artificial dataset which mimics the temporal pattern in real action data, which is the noisy MNIST data. And then it's 2 existing datasets, Breakfast Dataset and the TVSeries Dataset. Well, we show the results on the TVSeries Dataset. You can see from the reference 7, which is the dataset of the author, our baseline LSTM, the first row is already better, and our two-stream LSTM, which is in green color, improves results more, and we show 2 possibilities for the combination unit. Well, we only consider the RGB data here. Of course, you can do better with the optical flow data, but we are best appearance only. Flow would boost our results as well. Well, thank you for your attention, and if you have more questions, please come to the poster. Thank you.